What methods help find the optimal number of clusters? Imagine trying to organize a messy drawer filled with socks, shirts, and random items. You want to group similar things together, but how many groups should you create? That's exactly what choosing the right number of clusters in machine learning is all about. When working with data, especially in unsupervised learning, finding the perfect number of groups helps us see patterns clearly. Let's explore some ways to figure out that magic number without guesswork. One popular method is called the elbow method. Think of it like trying different sizes of a puzzle piece. You plot how well your data fits into different numbers of groups, called K. As you increase K, the total variation within each group drops. But at some point, adding more groups doesn't make much difference. That point looks like an elbow on the graph. Choosing that K helps you avoid overcomplicating your model. It's simple but can sometimes be a little subjective because the elbow isn't always obvious. Next up is the silhouette method. Imagine each data point wearing a tiny badge showing how well it fits into its own group versus neighboring groups. The badge score is called the silhouette score. A high score means the point is happy in its group and not confused with others. To find the best number of clusters, you look for the K that makes the average silhouette score the highest. This method gives a clear idea of how well your data points are grouped. Another approach is called the gap statistic. Think of it as comparing your data to a random, uniform distribution. You measure how tightly your data clusters compared to this random baseline. The best number of clusters is where your data's grouping is most distinct from randomness. This method helps avoid choosing too many or too few groups by giving a statistical measure of the clustering quality. There is also the information criterion approach, which uses formulas like the Okhike information criterion and the Bayesian information criterion. These are like report cards for models. They balance how well the model fits the data with how simple or complex it is. The goal is to pick the model that does the best job without being overly complicated. This method is especially useful when you can define a likelihood function for your data. Lastly, cross-validation is a tried-and-true method. It's like testing a recipe by making it multiple times. You split your data into parts, train your clustering on one part, and see how well it performs on the other. The number of clusters that gives the best performance across these tests is your winner. This approach helps ensure your clustering isn't just fitting the noise but capturing real patterns. All these methods help you find the right number of groups in your data. They're used in many applications, from organizing images with tools like DALL-E or Midjourney to analyzing text with ChatGPT. Picking the right number of clusters makes your data easier to understand and use. It's a key step in making machine learning models that truly reflected the patterns hidden inside your data.